This is how you supercharge your RAG databases. I built next level data prep flows for upserting documents into a RAG database. These things are awesome. Let me show you what they can do. All right, so right off the bat, you want to go into your Google Drive and you want to create a folder. It will be empty except for a single sheet that you will create. I'll show you that in a second, but first create a folder in your Google Drive for the purpose of what we're about to do. Then inside of that folder, create a sheet, and the only headings that you need in that sheet are the file ID column and upserted. That's it. And that'll all make sense in a moment. But first, don't be intimidated by all the rows. I'm still building this out, but this is so I can have multiple inputs because I want to be able to take a form and then in any form that I want to, be it a URL, maybe a file upload, a YouTube video, or even maybe a voice note, anything that I want to do that I would like to store in my RAG database, I'll be able to use this form and put whatever media I want into it, and then it'll turn it into what I need it to. But for now, I only have the one for URL on and working. So first things first, I have a form that triggers when I press submit, and one of the fields for it is a URL. So it takes a URL. This is a simple HTTP GET request, and all it does is it takes the URL, because what it's going to do is it's going to basically scrape that whole page. Like, that's what it does. When you GET request that web page, it'll take all the HTML from that page. Next, we have an HTML to text parser that take the data from that HTTP call, and it'll take all of those tags, all that meta information out. Then I have a text parser replace module. This is to get rid of all of the URLs, because every image will have a URL, every button will have a URL. I want that all out too. So this is the pattern that I'm matching. And then I replace it with an empty string, and there you go. And then what happens is I have all the words from a web page. So then I have to set some variables. And this is for chunking, because I want to chunk the data. It needs to be chunked when it gets upserted into a RAG database anyway, so this is how I do it. So the first variable is the actual text string, and then the next variable is chunk size. And that I set to 4,000. That's how many characters I want the chunk to be. Right, so I set those, then I have the repeater, it runs however many times it needs to be run for it to split it up in 4,000 or less character chunks. So this simple formula does that. Length, so it counts the number of characters in the text string, and then divides that by the chunk size. And that's how many times this is going to repeat. And then I have the set variable, and what this does, cuts the text string at 4,000 characters, right? So this tells it how many times it needs to do that, and then this actually does the cut. This chops it, so substring, text string, and then this little formula here, that is the cycle that the repeater's on, -1. Times the chunk size, and then that's the cycle again times the chunk size. So this formula right here will run it to 4,000 characters, chop it off, and then continue, and then the repeater will go do it again, etc., etc. You get it. Now I have the first prompt, and this is where it gets interesting, because we're not just cutting up data to upsert, we are prepping it to the max degree. So this is transformed to JSON so that we can use it in this HTTP API call to Open Router. I use Google Flash 1.5 for this, right? Because it's super cheap. But here, take the following block of text and apply the requested manipulation to it, right? And then here's the text, so that's the 4,000 character chunk. And then the requested manipulation is to clean this text by removing unnecessary characters, metadata, menu items, header and footer data, or other relevant information, because this came from a scraped web page. Remember, it's going to take all the words off, which includes menu words that were in the menu items and all that. So the AI is now aware, hey, this is a scraped page, and I just need you to remove all the unnecessary stuff. All right, so we ask Google Flash to do that. And then the next prompt is to suggest a list of relevant hashtags for proper text categorization to make retrieval from the vector store more easily. Yes, I referenced the vector store because it's in the system prompt. Sorry, I skipped over that. The system prompt is that you're a text preparer for a vector data store. You take bodies of text and clean and format them, apply tags, and perform other manipulations. So the AI is now aware of its job, and then this second prompt tells it, okay, now for better categorization, we need hashtags. And then the third prompt is asking for a question and answer chain. So create a chain of question and answers based on the provided text. Create the questions that a user may ask about the text, and then use the provided content as the basis for the answer. Ignore incomplete sentences. So it takes the chunk, cleans it up, And then after it cleans it up, it applies hashtags and then some question and answers, which is awesome because this is going to make the data chunks so much easier to retrieve and the context will be a lot richer, right? Then we have an increment function here. Then we send it to Google Drive as a TXT file, right? So that's where that folder came from. And then we put the increment number in front of it. So the file name is always different because the increment will never run out. So it'll go from 1 to infinity. And then I label it tags, and then those are the hashtags, the content, which is the cleaned content, and then the Q&A, right? That gets saved as a TXT. And then after it gets saved as a TXT, we save that file ID in that first column in our sheet. All right, do that for however many documents that you want. Once that's done, we move over to NA10. I know that sounds weird, right? Why are you using two different no-code platforms? The reason is because NA10 has native integration with Langchain functions, and one of them is native integration to upsert documents. Now, yes, we can upsert them through Make. I have shown you how to upsert them. Here's the one thing that I don't like about the process on Make. Through Make, you can't overlap. So overlapping is where a little piece of the end of the last document is overlaps with the beginning of the first document. So that helps preserve context, right? Because you're splitting everything up and you want at least some of it to be connected so that the AI has an idea. Like when you do a search and it pulls, two chunks that are related, connected, the context is still there. Anyway, and you can't do that, or at least I don't know how to do that through Make. So that is a process that's automatically built into this system in Natin. So how this flow works is first I have the Google Sheet, right? And what the Google Sheet is doing is it's looking for the rows in that sheet, right? So it's looking for the rows from this list on this sheet, and it's specifically looking at the column upserted to see if anything's there. It's looking to see if there's nothing there, actually. That's what it's looking for. If there's nothing there, that means it hasn't been upserted yet. It's going to grab the last row, right? So then we download the file based on the file ID from that column in that sheet, right? So it's looking to see that nothing is there, right? So this starts with empty. There's no yeses there. And then once it sees empty, it grabs this file ID and it uses that to download that TXT. Once it's downloaded that TXT, then we have the QDront vector store, right? So QDront vector store with the collection ID. I'm using OpenAI embeddings, text embedding 3 small, the default data loader, binary text, right? Because that's a TXT file. And then the recursive character text splitter. I set the chunk size to 12,000 because we added hashtags and Q&A. So even though the chunk was 4,000, I added a bunch, and I want to get the whole chunks, right? So I put this at a really high number with some 400 character overlap. And then once that's upserted, we come over here and we add a yes to that column, right? So we match by row number, and then we add a yes to the upserted column, right? Because it's been upserted. We don't want it to upsert again. And then we loop all the way back here, and it goes through every single file until all of them have a yes next to it. And that's it. And that's how you get, not only is this a really just convenient way to get files upserted, right? Files of all kinds, like I said, URL, YouTube video, file upload of different types, files of all kinds. Not only is it a convenient way to get files of all kinds, chunked, split, and put into your vector store, but it's genius because we're using AI to prep the data to make it more easily searchable. Anyway, I'll actually show you what that looks like. So here it has the tags, it has the text, and it has the Q&As, and they're all labeled. And when we pull this data, when we run a query, API call, and pull this data, it's just so much easier to retrieve. All the context is there. As well as all of the pertinent information. It's a beautiful way to do it. This makes sure that exactly what you need is pulled whenever you query your RAG database. So I hope that helps. Cheers.